Thank you to the conference organizers for the opportunity to present these results. Today, I will be presenting on the time course of tenofovir diphosphate carryover in dry blood spots following TDF to TAF switch. I have no disclosures to make. Tenofovir diphosphate in DBS is an important tool for assessing adherence to TDF and TAF-based therapy. It's reflective of cumulative dosing over the previous 2 to 3 months owing to its long half-life of 17 to 20 days in red blood cells. It also demonstrates strong relationships with clinical outcomes in persons on PrEP and persons with HIV. Tenofovir diphosphate levels are approximately 10-fold higher with TDF in comparison to TAF in red blood cells. This results in the need to assay differing DBS punch sizes, as shown in the figure on the right, where for TDF we assay a 3 mm punch size in comparison to TAF, where we assay a 2 by 7 mm punch size. Ultimately, this results in us being able to achieve similar dynamic ranges of tenofovir diphosphate, as shown in the table on the right. However, assaying larger punch sizes may amplify residual tenofovir diphosphate from TDF in persons switching to TAF. The objective of these analyses were to characterize tenofovir diphosphate carryover in DBS following TDF to TAF switch. The DBS samples used in these analyses came from a study where we were comparing the plasma and intracellular pharmacokinetics and renal safety of TAF, boosted PIs, and ledipasvir sofosbuvir in persons with HIV. A total of 10 people were enrolled. Adherence was monitored using wise pill devices throughout the study. In phase 1, participants continued their TDF with a boosted PI for 12 weeks. In phase 2, they switched to TAF 25 milligrams with a boosted PI for an additional 12 weeks. In phase 3, we added on ledipasvir sofosbuvir for a period of 4 weeks. And in phase 4, they resumed taking TAF 25 milligrams with a boosted PI for an additional 12 weeks. Blood was collected at the end of each phase, including DBS. Tenofovir diphosphate was quantified using LCMS methods. For TDF, we assayed 1 by 3 millimeter and 2 by 7 millimeter punch sizes, and for TAF, we assayed 2 by 7 millimeter punch sizes. In order to probe the potential influence of residual tenofovir diphosphate remaining from TDF, we calculated the amount of tenofovir diphosphate remaining from the 2 by 7 millimeter punch size by taking the concentration that was measured at the end of phase 1 in participants on TDF, and then for the elimination rate constant, we used a value that corresponded to the median IQR half-life of 17 or 15 to 20 days from previous TDF studies that have been conducted. And for time, it was time post-TDF switch in relation to when the PK assessments took place in remaining phases of the study. We then took that amount residual that was calculated and then divided that by the amount of tenofovir diphosphate that was measured throughout the remaining TAF phases. Here I'm showing you the tenofovir diphosphate concentrations in DBS across the various study phases. I first want to call your attention to the TDF results. So these concentrations reflect the 3 millimeter punch size that we generally use. You can see that in comparison to the 2 by 7 millimeter punch sizes that were used to assay TAF, overall the concentrations are generally comparable for the differing punch sizes with the two different prodrugs. Where we started to think that tenofovir diphosphate carryover might be an issue is that if you assay the 2 by 7 millimeter punch sizes for TDF, the results are approximately 14-fold higher in comparison to the 3 millimeter punch size with TDF, as shown with the red dots. So when you do the initial comparison of TDF against TAF between phases 1 and 2, the TAF results, they were 81% lower when comparing the same 2 by 7 millimeter punch sizes. But then what we noticed is that between phases 2 and 3, results were 11% lower, and between phase 2 and 4, the DBS concentrations were 15% lower after controlling for adherence. So you can see that the tenofovir diphosphate concentrations continued to decline following the TAF switch. On this slide, I'm showing you the decay of residual tenofovir diphosphate with TDF from the 2 by 7 millimeter punch size. The x-axis at time 0, this is corresponding to the day that the TDF to TAF switch occurred. So in this example, we're starting from the minimum value that was measured with TDF with the 2 by 7 millimeter punch sizes for the DBS. And you can see that 4 to 5 half-lives later, visually in comparison to where it started, it doesn't look like too much is remaining. But even with that 3 to 6% that you'd estimate for the 4 to 5 half-lives later, assuming a half-life of 17 to 20 days, you could still potentially measure 388 femtomoles per 2 by 7 millimeter punches from that residual tenofovir diphosphate from the TDF, again, from the 2 by 7 millimeter punch size. Again, this is showing this similar concept of the decay of residual tenofovir diphosphate with TDF, again with a 2 by 7 millimeter punch size. Again, day 0 corresponds to TDF to TAF switch, but in this case, we're starting at the maximum value that was measured in a participant with TDF with that 2 by 7 millimeter punch size. And again, using that similar concept of around 3 to 6% remaining, approximately 4 to 5 half-lives later, you can see that that amount would correspond to a measurement of 2,942 femtomoles per 2 by 7 millimeter punch size. Again, in this case, assuming a 20-day half-life or more of the extreme of the upper bounds that have been measured in previous studies. Here I'm showing you overlays of the residual tenofovir diphosphate remaining from TDF relative to the TAF DBS concentrations that were being measured across the different study phases. So the lines reflect the residual tenofovir diphosphate remaining from TDF with the 2 by 7 millimeter punch size, and the bars and lines reflect the geometric mean 95% confidence interval measured in each of the TAF phases. So for these gray lines, these reflect the minimum, geometric mean, and maximum tenofovir diphosphate concentrations that were measured with TDF in phase 1, again assuming a half-life of 17 days in these cases. And you can see with the overlays that depending on where people are starting in this specific study, that the residual tenofovir diphosphate could potentially be accounting for anywhere between a geometric mean of 17 and range of 9 to 34% of what's being measured in TAF DBS in phase 2. And again, this was 12 weeks after that initial TDF switch. In phase 3, this was 4 weeks after the phase 2 assessment. The residual tenofovir diphosphate levels remaining were lower. Again, though, there's a range of potentially 3 to 11% of what's being measured in TAF at that phase could potentially be due to residual tenofovir diphosphate from TDF. In phase 4, which was 12 weeks after the phase 3 assessment, you can see that at this point, there's very little residual tenofovir diphosphate remaining from TDF relative to TAF. Assuming a 20-day half-life, which again was the 75th percentile of what's been measured in previous studies with TDF, you can see that the residual amount remaining in this case, again a bit more of an extreme, it falls below 5% relative to the TAF DBS levels that are being measured approximately 22 weeks post-switch. So in conclusion, carryover of TDF to TAF switch may significantly affect DBS adherence interpretations. The contribution of residual tenofovir diphosphate from TDF depends on the time frame of assessment and levels at the time of switch. Among those was steady state and good adherence. In this study, the impact of residual tenofovir diphosphate is negligible approximately 5 months post-TDF to TAF switch. So researchers and clinical providers should wait at least 5 months after switching from TDF to TAF for comparisons of tenofovir diphosphate against adherence gradients. And with that, I'd like to thank the study participants, members of the Colorado Antiviral Pharmacology Laboratory, our statisticians in the School of Public Health, our collaborators at Denver Health, and also clinical staff at the CTRC, and also Gilead for funding this study in addition to NIDA.